Hello and welcome back to our tutorial series explaining how to use the new carbon glow garment processor welded and unwelded in Maya and Houdini. In the last video, we showed how to export a cloth simulation or like a cloth setup from CLO 3D so it can be used. And now we find ourselves in Houdini and we are going to set up an unwelded garment actually. Let's do this. All right, first of all, we got to create a sub network. So create a geometry. I'm just going to call it simulation. Let's go inside. All right. Next thing, create a file node, and we're going to load the unwelded obj file. So going down here, unwelded obj. There we are. All right. We see a few visual distractions, which I'd like to take away. So we see the UVs being displayed. I'm just going to click this. And also we have the viewport set to specular highlights being shown, and I will remove them. And there we go. All right, next up, we want to check that the UVs have been exported correctly. So in Houdini, if you mouse over the viewport, you click space and 5, and you go to the UV view. In the UV view, we can now see that our UVs are correct because they are the same layout as they were in the 2D pattern view and the UV setup in CLO. If you, for example, forgot to tick unified UV coordinates in the export of the OBJ file, they would all be over on top of each other basically. But this looks good, so we press space and 1 and we're back to this view. Another shortcut to use often is space and A, which just centers all the geometry in the viewport, so the camera around it. So if I go away and press space A, we're back here. And then I always use Control and S to just save from time to time. So in the bottom left corner, you see it saying successfully saved. So that's just what I use from time to time to maneuver around. Okay, next up, let's create another file node. And we are going to import our avatar. Here it is. Perfect. And then we're gonna bring in the third file node. We're gonna bring in our render meshes. So, and render, and as FBX. So another option to bring in render meshes could be via the labs FBX archive import, but this labs node needs to be installed during the installation process, the whole side effects labs. So if you don't have it, you're not gonna, like if you didn't install it, you're not gonna see it. But what it does is it also usually has textures on it. You see it, the white texture. Obviously, if you had a more sophisticated texture in CLO, we will see that here, but it's just white. So for the purpose of this, let's remove this and just use a basic file node, which everyone should have available. All right, now we're here. We need to split up our render geometry because here we have our details and our render geometry, and we want to split them up so we can process them separately. So how do we split it? Actually, we use a split node in Houdini. All right, here we can then select how to split it. And in the dropdown, in the shop material path, there's only two different ones. One stands for the main panels and one is for the details. And select the first one and we see the details have disappeared, which means that this one represents the main panels. Let's add another node to the second output and we will see our details. Space A, and we center around it, nothing missed, nothing added, all good. Let's rename this. Beautiful. All right, and then we obviously have the other one. I'm also gonna call null here, call it render. There we go. Perfect. All right, what's next? Next, well, let's create a garment processor node. Oops. Garment. There we go. Carbon glow garment processor unwelded. And we can already tell here we need a simulation, we need an XML file, and later in the simulation setup, we will need a cloth material. So I usually just like to get these out of the way. Let's create a carbon simulation node and middle mouse button, click on the avatar, and we see that our size in Y, so the height is 186, which makes me think, well, the avatar is probably in centimeters, and that's correct because that's how we exported it from CLO as well. So 186 centimeters, which means we need to set the scene scale on the carbon simulation node. By default, it assumes that scene units are in meters, but since we're in centimeters, we gotta scale it down 0.01. Now it's all correct. And then I like to set the subdivisions to 30 just to have a little bit more simulation effort behind it. Just gives you better results. All right. Then let's add a cloth material, carbon cloth material. All right, thickness. We are in scene unit centimeters. If you want a thickness of, let's say, 1 millimeter, we need to set to 0.1 is 1 millimeter. Then I usually just add a 0 to the stretch stiffness to make it a bit stiffer, and viscosity to 2, and bend to bend viscosity. That's enough. That's good for now. All right, now we want to press maybe Control S, save the scene. Perfect. All right, let's go into a garment processor, Unwelded. All right, first input, we need the start panels, the start meshes, which we have here. Second input, we need the render panels. And third, we need the render details. All right, up here, simulation. We need to point to the carbon simulation node. XML file, we need to point to t-shirt unwelded metadata that we exported. And the simulation tab, before I forget about it, let's just set to the material. Perfect. All right, you can see that we still have an error on it, and it's a bit of a complicated Python error, but basically, when you can see us get name from point index, when you see this kind of error, means that we are missing a name primitive attribute on our start mesh geometry. You can see that we have 7 primitive groups, but we have no primitive attribute called name. So the carbon garment processor here actually requires to have a name attribute, which is going to be used for like naming cloths and so on. So we can use in Houdini, we can use something called name from groups. And this is a node that takes groups and converts them to a name attribute. We have a class primitive, attribute name, and group mask, just a star. And now if we go on here, middle mouse button, we see name, 7 unique ones, because we have 7 primitive groups. Okay, we go back to this one. That's yellow, flag on and off. And sometimes it just shows, there we go, now it's gone. And we have no more errors on it. Perfect. All right, let's save again. And we can move on. All right, so in the garment processor, now we're gonna work our way through these tabs to complete the setup. And we're gonna start with creases, which is also set in our guide visualization here. It's at guide type creases. We don't see anything because we haven't set any creases yet. If you press create creases, it will use the metadata in the file to find all of the folds that were exported. Also stitching and folds that were exported from CLO. We just call it creases here. So press create creases. We see 23 have been created. You can see a visual representation of each crease as a colored tube. And the properties of all creases are set here. So let's see what this all means. Thickness in the guide visualization just makes the tubes thicker or thinner. That's it. Let's go back to default. All right, single crease means you can just display one. So here we have our single crease, or you can just loop through them basically here. Or we just show all creases. All right. Color seed is just a random number used for the color generation. If I change this now, nothing's going to change. You basically have to clear this and create creases again, and it would use a different seed. The group prefix, I would just leave it like this unless it specifically clashes with any existing groups you use in your organization. We have enable and disable all creases, which is just like a macro to just tick and untick all of these. If you disable one, we're not going to apply basically the angle and the fold strength on a certain crease. The strength and the angle are based on the data from the XML file, which comes from your setup in CLO. If you're playing around with it and you ever wonder, oh, what was the original number that was in the XML file? Well, it's right behind it in brackets. So you can go, oh yeah, it was 0, let's go back to it. All right, for each of them, you can click on the color. And as you can see here, crease 1, if you change it, it changes blue, red, green. So you can specifically set your colors for each crease as you want, or just stick with the default. Now you're probably thinking, well, a lot of these colors here seem very similar. How do I know which one of these actually corresponds to which of these? So what you do is you go on select here, the left select, and up top in the select dropdown, you go to geometry groups. Let's make this bigger. And we have geometry group for each of the panels and for each crease. So if I go over the creases, you can see creases are being highlighted. Or you can just hover over crease in the viewport and you'll see the crease highlight. So this is crease 18, crease 12, and so on. And then there's the number crease 12, obviously is here, crease 12, and you can enable, disable, strengthen, angle, all of those settings. So that's basically how you figure out which one is which. All right, just press this button here and you can go back to camera view. All right, that's basically the creases setup. I'll just keep it as it is for now, and then later, if you want to fine-tune the simulation, that's when you go back here and change maybe the angles or the strength. Next tab, geometry setup. What this does is actually remeshes this Delaunay mesh into a geometry suitable for the carbon simulation that's just best suited to apply anisotropic parameters. So that is weft, warp, and bias. You can, so carbon still applies anisotropic values if you have a Delaunay mesh like this, but it's not as strong or as efficient as if you have a proper tessellation. So all you need to do is press create geometry subnet. And this will create a new subnet here where you have your original mesh and you run the carbon remesher, and you can see that it is basically an axis aligned grid and here triangles. And it preserves all of the crease lines and internal lines from the XML file. But usually you don't really have to do much in here. Unless something majorly goes wrong, you can just then move on and go to create simulation subnet. All right, and now we have another subnet here. We have our simulation network. And what we get in here is basically for each cloth, so for each panel, we have a cloth that's created. It has in start mesh, cloth, reference mesh, goal mesh, and it brings in the creases, which are linked to the UI up top on the garment processor in terms of angle, strength, and so on. And then they all come together and we have stitchings, and all these stitchings are basically one for each of those creases where two panels meet. So again, these numbers were created from the XML meta file. So we only have stitchings that actually exist. And for each stitchings, we have a narrow filter that just prevents collision issues where two panels meet tightly. Also, just to note, because we've moved on to simulation setup, what happened in the geometry setup is that the start and the reference meshes have been locked here now, so they're baked into the scene. So the reason for this is that when you reload the scene, you don't have to run through the carbon remesher every time, which can be slow if you have a very complex garment. So you don't want to have to do this every time, and you want to just lock this in the scene and save yourself some time. All right, we have the simulation set up. What do we do? Let's just hook it up to the simulation. Maybe we save first. All right, let's go to the simulation. And there we are. All right, let's press play. And obviously our t-shirt falls down. All right, so that means we probably want to add our avatar. There can only be one input to the carbon simulation, so we need to add our merge node. And we have our avatar here. Add a collider, a carbon collider node. Oops, don't go inside, nothing in there. Thickness, let's set it to 1 millimeter, so 0.1. And let's remove the animated tick box because we're not animating, obviously. Connect it, reset the simulation. And here we are, let's simulate this. All right, that looks good. Beautiful. All right. I'm gonna press L and H when my mouse is over this graph, which then will lay out the graph. So L and H, and it will lay out and center the graph, so it looks very nice. All right, at this point, simulation basically is set up. We can obviously tweak the cloth material, which is linked to all of the cloths inside. Tweak that, tweak our collider, tweak our simulation parameters to our liking. But what else can we do? Remember, we exported our render meshes here and our render details. So now we want to basically use them in a way, right? So we have carbon mesh deformers, which can deform these thick high-res render panels based on the simulation geometry. So how do we do this? We go back to our garment processor and we go to the next stage, detail mapping. What this does is map each of these details to a matching render mesh, so that later details will be deformed based on the render mesh. So we just click create mapping, and this just runs a proximity test. All right, and we can see here, currently it's not really mapped to anything. So why is this? This is because if we go here on our render mesh middlemost button, we have a center, X is fine, Y is fine, but Z is 20. So for some reason, CLO exports these flat panels not perfectly in the XY plane. It always sets a set value of 20. So to fix it, add a transform node and just want to set to -20. And then we're basically back in business. Make sure to use it before the split so it affects both the render and the details. Right, let's go back here. Let's clear this and let's create mapping again. And there we go. We have these details and now they're mapped to render panels. Perfect. All right, so you can actually visualize this. Here we're still showing the creases, but up in the guide visualization, we change it to mapping. And now we see different colors for different panels. So these are our cloth panels, 7 of them, 1, 2, 3, 4, 5, 6, 7. If you use this seed, it immediately changes the color. You can also take it off. And when we zoom in, we have our details, which the way it just came out of CLO is automatically detected as 4 different geometries. And they're all mapped to panel 60, which is this one because it has the same color. If I was to change this manually to something else, you would see that this one is now a turquoise color, which I guess corresponds to this panel. So you can see, oh, this one really visually, this detail is supposed to map to this panel, but it's the wrong one. So I'm going back, 60, there you go. It's just a nice verification. Let me make it smaller. All good, coloring looks good. We obviously only have those details. And we can move on to the mesh deformers. Actually, let's undo color panels. There we go. Mesh deformers will automatically create it if you create a deformer network here. Boom, there it is. Carbon CLO garment process unwelded deformer setup. A long name, isn't it? But it's basically taken the garment processor name and then just adds deformer setup, similar as it does to the geometry and simulation setup. And in here, we have basically a deformer setup for each panel. Each panel, you have the deformer main and the deformer details, which are linked to the garment processor UI. And that's basically it. You can just run this and it's automatically deforming. Let's add a merge and bring it together with our avatar. All right. One thing to keep in mind is also that there is a chance that there are already normals on this mesh. Yeah, we have normals, which might have been baked in from the CLO export. So you want to maybe delete or recalculate the normals. So let's add a normal node. All right, and usually I use the cusp angle high. All right, so our normals are now being recalculated. So if we were doing this, it sometimes when it has this normals baked in looks off. But it's good practice to always just check what the normals do. But yeah, so here we have the setup. It looks very nice. All in all, the main graph is not that large. Obviously, everything is kind of hidden inside. But yeah, I hope this all made sense and you learned something and hope you have fun using this. Thank you very much.